Assalamu alaikum. So we have a Arduino here, and from Arduino we can only get 0 and 5 volt. That means, let's say you want 1 volt or 2 volt or 2.5 volt. So from Arduino you can directly obtain this value because the Arduino only gives you 0 and 5 volt. But let's assume that for some project you want these voltage levels. That means you want the voltage from 0 to 5 volt. So how can you get this from Arduino? So in this with a simple technique you can obtain this voltage from 0 to 5 volts. So let's start. Let's see how to do this. So to do this we have to use a PWM pin, and in this video we will use PWM pin 6. So let's check the Arduino. You can see a symbol before 6. So this is the PWM sign. You have another PWM pins like 11, 10, 9, 3, 5. But in this video, remember that in this video we will use the PWM pin 6. Okay. So we will use the PWM pin 6. So if I write an analog write function in my Arduino code, then from the Arduino I can obtain a square wave like this. So this is a periodic square wave, and this let's say this is the voltage from pin 6, where the time period is t, which is equal to 1 millisecond for this pin 6, and for the time t1 the voltage value of this square wave A is equal to 5 volt. So we can't change this time period t, it is fixed, but we can change the value of t1, and by changing the value the duration t1 we can change the value from 0 to 5 volt. And here t1 divided by t is called the duty cycle of the square wave, so we need this. Okay, so now we need to find the equation for the square wave, and to find the equation of the square wave, the equation of the square wave looks like this. Okay, so this is the voltage of the square wave. So I have made a video on how to find this equation using Fourier series expansion, but for the time being just accept that the equation of the square wave looks like this. If you notice this equation, you will see that you have a DC part here, or it is called the DC offset. As it is DC, that means the frequency of this part is equal to 0, and you have some higher frequencies at the second term. You have some higher frequencies here. Observe here, these are some higher frequency terms, and you also have some higher frequency terms here. So you also have some higher frequency terms here. So what we will do in this video, we will make a simple low pass filter. So we will simply make a low pass filter, and we will pass this square wave, I mean this V, which is obtained from pin 6, the PWM pin. We will pass this square wave in this low pass filter, and if I do this, the higher frequency terms will be cancelled out, and we will only get output voltage is equal to AT1 divided by T. Why? Because it's the low pass filter, and as its frequency is 0, so only this term can pass through. Okay, so output voltage is this. So P0 is equal to what is A? A is the maximum voltage of the square wave, that is for Arduino it is 5 volt. So let's write here 5, and T1 divided by T is called the duty cycle. So by changing this duty cycle, we can change the value of V0 from 0 to 5 volt. So now let's talk about the analog write function again. We have to write this function in our Arduino code, as we want the square wave from 6 number pins. So let's write here 6, and we have to write a number n here. So if n is 0, the duty cycle of the square wave from pin 6 will also 0%. So if duty cycle is 0, from this equation the output will be equal to 0. And if n is the maximum value 255, then the duty cycle will be 100% or 1. Then the output voltage will be, if the duty cycle is 1 or 100%, the output voltage will be 5. But now let's say you want a voltage, let's say you want 3 volt or 4 volt, or let's say you want 3.5 volt. So you have to adjust that n. So what will be the value of n? Let's see. When you get 5 volt, if the output is 5 volt, the value of n is 255. But when the output is V0, it can be anything, 3, 4, 5, etc., then the equation of n will looks like this. So we have to apply this equation in our code. So let's start. So let's go to the Arduino IDE. Let's erase this thing. Let's do this from the beginning. Okay. So first, we want the output voltage, which is equal to, let's say, 3 volt. And to obtain 3 volt, our equation of n will be 255 divided by 5 into V0. Okay. Now as you want the square wave from pin 6, so let's take pin 6 at output mode, and at the void loop function, let's use that analog write function 6 and write here n. Okay, so now verify this code. Okay, let's verify this code, and you can upload this code to your Arduino IDE. And as I am using this Proteus, and so I have to upload this to this Proteus file, so it's easy. Just I have to go to here, then I have to go preferences, then I have to ensure that a click mark is on the compile, show verbose output during compile, then I will press OK. Then if I verify this code, then I will get a lot of text here. From this text I have to find a hex file location. So this is the location of hex file. Let's copy this hex file and then go to the Arduino, double click here, and then on program file you have to paste this hex file location. Now click OK. Okay, so the function of Arduino is done. Now we have to design this low pass filter. Okay, so let's design this low pass filter. So this simple RC circuit is our low pass filter. Okay, so this is the input voltage V, which is simply the square wave, and this is the voltage from pin 6. Let's say this is R and this is C. So and the cutoff frequency and the graph of gain versus frequency graph looked like this. So this is the low pass filter, as it can pass only the lower frequencies and cut the higher frequencies. So now so this is our cutoff frequency. So we have to design a cutoff frequency here. As I have told that the square wave's time period is around 1 millisecond, and the cutoff frequencies equation is simply 1 by 2 pi RC So and fc is 1 by t is equal to 1 by 2 pi rc. Okay, and t is equal to 1 millisecond. Then 2 pi, let's say we have choose a capacitor of 1 microfarad, so it's 1 microfarad. Now we need to find the value of R, and if I calculate it, I will find the value of R is equal to around what the value of R will be equal to wait. Okay, so if I calculate it, the value of R is 159.154 ohm. Okay, so let's design this. Our capacitor is 1 microfarad and resistor should be 159 ohm, or you can choose a value which is available to you around this figure. So now if I try to find, this is our output voltage, sorry, this is our output, this is our output. So if I want to find the output voltage, let's see what is our output voltage will be. Oh, wait a minute. Oh, sorry, I have made a great mistake here in doing this sorry, wait, let me explain what was the mistake. So our goal was to cut this higher frequencies, right? Our goal was to cut off these higher frequencies. That means what is the fundamental frequency of this square wave? This is equal to 1 by t, which is equal to 1k. That means we want to cancel this 1k or 2k or 3k, whatever the frequencies are. We want to cancel this frequency, right? And to do so, we have to choose a lower cutoff frequency. And let's say for my case, I choose only 100 hertz. That means only 0 to 100 hertz signals can pass, but 1k, 2k, 3k, as these frequencies are higher than 100 hertz, so these frequencies can't pass. Okay, so to design this filter, we have to apply this equation fc is equal to 2 pi rc. So fc is equal to 100, then 2 pi r into our capacitor was 1 microfarad. So what will be the value of our resistor? It will be equal to it will be the value of this resistor will be equal to 1591. Wait, okay, so 1591 ohm. Okay, so let's put this value to my simulation file. So this resistor's value is 15915 ohm. And now if I run the simulation, let's see what happens. So the value is 3 volt, but I'm getting some higher frequencies here, some oscillations here. The voltage is around 3 volt, but I am getting too much oscillations here. So what I can do, I can make this filter something better. Let's say fc is only 10 hertz. So if fc is 10 hertz, then the value of R will be equal to Okay, I think it's okay. Okay, now let's change this value, let's say 3.5, and if I verify this code, and then let's go to the Arduino and let's see now what is the voltage level. It should be 3.5. so let's see, is it 3.5 or not? Yes, the voltage is 3.5. So by using a simple low pass filter, you can obtain any voltage from 0 to 5 from this. Okay.